Welcome to the Explainer. Look, if you're an engineer, you've probably been there, trying to stuff a massive document into an LLM, only to hit that dreaded context limit. It's a huge pain. Well, today we are diving deep into a new hybrid architecture that is absolutely smashing through that barrier.
All right, so here's the game plan. First, we're going to break down why transformers choke on long inputs. Then, we'll look at Mamba, a totally different approach. After that, we'll see how Jamba cleverly combines the two. And finally, we'll get practical and see what it's like to actually build with this thing.
So first up, the transformer bottleneck. You know, it's kind of funny. The transformer is the architecture that basically started this whole revolution. But its own success has created a massive problem for us.
So here's the big question. Why can't you just give a standard LLM a whole book and ask it questions? You've probably tried something like this, right? Feeding it a huge code repository or a long chat history, and it just falls over. Well, the reason isn't just about running out of RAM. It's way deeper than that. It's a hard computational limit baked right into the DNA of the transformer.
Okay, so what makes transformers so powerful in the first place? It's this one magic ingredient, the attention mechanism. You can think of it like this. For every single word in a sentence, the model literally stops and compares it to every other word in the entire document. This is how it figures out that it, in a paragraph, refers to a cat mentioned 10 pages earlier. It's this all-to-all comparison that gives it that incredible, nuanced understanding of context. But, and this is a huge but, that superpower has a crippling cost. Take a look at this. The complexity is O of n squared, or quadratic. What does that mean in plain English? If you double the length of your input, you don't just double the computation, you quadruple it. Double it again, and it's 16 times the work. You can see how this spirals out of control, right? This is the infamous quadratic bottleneck, and it's the reason why feeding a transformer a novel is just not going to happen. It's computationally and financially just way too expensive.
So that quadratic bottleneck was a brick wall. And smart people, when they hit a brick wall, don't just keep banging their heads against it. They look for a different way around. And that brings us to a completely different approach, Mamba. Mamba is built on something called a state space model, or SSM. Now, instead of that crazy all-to-all comparison, an SSM works a lot more like, well, like you and me reading a sentence. It goes through the text one token at a time. As it reads, it keeps this compressed little summary in its head, a state of everything it's seen so far. The key here is that it's just updating that state with each new token, and that simple change completely transforms the complexity. It's not quadratic anymore. It's linear, or O of n. Double the text, you roughly double the work. Game changer. But Mamba isn't just any old SSM. The real magic is in its key innovations. The big one is something called Selective State Spaces. This is brilliant. It makes the model's parameters dependent on the input it's seeing right now. This gives it the power to dynamically decide, on the fly, okay, this piece of information is super important, I'll keep it, or you know what, this detail isn't relevant anymore, I can forget it. And they designed this whole thing to be super efficient, to run incredibly fast on modern GPUs. I love this analogy from IBM because it just clicks. Think of that compressed state, that memory, as a mixing board with a bunch of volume knobs. Each knob controls how much a certain piece of past information influences the future. As Mamba reads, its selection mechanism is constantly adjusting these knobs. Is the current word related to something from 3 paragraphs ago? Cool, turn that knob up. Is it starting a new topic? Great, turn the old knobs way down. It's a selective, dynamic way of managing context. Okay, so linear time, selective state, this sounds perfect, right? Well, not so fast. There's always a trade-off. Because Mamba is compressing all that past information into a single state, some of the fine-grained detail can get a little fuzzy. It can be lost. So for certain tasks, like when you need to precisely compare one specific sentence on page 5 with another specific sentence on page 500, that brute force, all-to-all attention mechanism from the transformer, well, it's still the king. And it's this exact trade-off, this tension between two different approaches that sets the stage for our main event, the hybrid advantage of AI21's Jamba. The folks at AI21 Labs looked at this whole situation and had this really elegant insight. They realized, hey, wait a minute. Mamba is fast but can lose detail. Transformers are detailed but slow. These aren't competitors, they're two sides of the same coin. So instead of trying to declare a winner, they asked a much better question. Why not use both?
And this is how they pulled it off. It's so clever. They didn't just bolt a transformer onto a Mamba. They created this interleaved or layered architecture. Think of it like a sandwich. You have a few layers of super efficient Mamba, doing the heavy lifting, processing the sequence quickly, then bam, you insert a layer of transformer attention. That attention layer gets to look at everything at once, like a manager doing a spot check, making sure all the long-range connections are solid. Then it's back to Mamba layers, then another attention layer. It's the best of both worlds in every single block.
And what's the payoff for this hybrid design? Look at these numbers. A 256,000 token context window. That's not just an incremental improvement, that is a massive leap. We're talking double what GPT-4 Turbo offers. Jamba can handle these enormous context lengths because the Mamba layers do all the efficient heavy lifting, which makes it practical to use those powerful but expensive attention layers where they count the most.
All right, theory is great. But what does a 256K context window actually let you do as an engineer? Let's get our hands dirty and talk about what this looks like in practice, in your code.
Okay, here's a classic scenario. You've got a massive project discussion from a Slack channel. We're talking thousands and thousands of messages, maybe 50,000 tokens long. With a standard transformer, what do? You have to write all this painful code to chop it up into smaller, digestible chunks, feed them in one by one, and then try to stitch the answers back together. It's a mess, and you always lose important context at the seams. Now look at this. This is the code to do the same thing with Jamba. And what's amazing is what's not here. There's no for loop for chunking, no complicated logic for merging results. You literally just import the client, point it to the Jamba model, and throw the entire 50,000 token conversation at it in one shot. All that complexity we used to have to write ourselves, it's gone. It's been pushed down into the model's architecture where it belongs. This is a huge win for developer experience. And because Jamba has the full, unbroken context, the quality of the insights you get back is just on another level. It can give you a perfect executive summary. It can pull out every single action item and tell you who's responsible because it saw the whole conversation. It can spot an issue raised in the first 10 messages that was never resolved by the last 10. You just can't get this level of coherence when you're working with fragmented chunks of text. So let's just put it side by side because this really says it all. The old way, multiple API calls, messy code to manage chunks, guaranteed context loss, and a cost that explodes quadratically. The Jamba way, one single pass, one API call, perfect context preservation, and a cost that scales pretty much linearly. From an engineering standpoint, it's just a fundamentally better, cleaner, and more powerful approach to the problem. Okay, so let's zoom out and recap. The big takeaway here is that the one architecture to rule them all era is probably over. Transformers are amazing, but their quadratic complexity is a real-world constraint. Mamba comes along with this super efficient, linear approach, but with its own trade-offs. And Jamba shows us the future is likely hybrid, cleverly combining different architectures to get the best of all worlds. This is about using the right tool for the job, and it unlocks applications like handling 256K contexts that were just a pipe dream before. So this progression, from pure attention to selective state, and now to these powerful hybrids, is a huge deal. It's making problems that used to be basically impossible, or at least ridiculously expensive, totally practical. Think about analyzing an entire codebase or a whole library of financial reports in a single go. That's on the table now. So the real question I want to leave you with is this. Now that we've conquered long context, what's the next big engineering challenge that these new hybrid architectures will help us solve?